Welcome back, CIS 2531. Here's another tutorial, but this time it will be on strings. So this is chapter 8 out of your textbook. If you haven't read chapter 8 yet, I'm going to strongly suggest that you go through and read that first and foremost so you get all the little details. This is going to go over just some of the finer points. But yeah, if you haven't read it, go back and redo that real quick and then come on back to this video if need be. But either way, with strings, you're going to find that strings act very similar to lists and tuples from the previous videos in the previous chapter. The thing about strings, though, is when compared to lists, is they are immutable sequences, so they're a little bit more like tuples in that nature. And we've already worked with strings a little bit, so you should be somewhat familiar with them. Today we'll just go over some of the finer details. So first and foremost, the first part that I want to go over is right here. String concatenation, if you haven't figured this part out, string concatenation is the idea where we are simply adding strings together. So the plus sign operator is an overloaded operator, much like we can have overloaded functions, things that can do different things. Where it can act differently between different pieces of information. If you put the plus sign between a 3 and a 5, adds it makes 8. But if you put the plus sign between two strings, what it does is it combines or joins those two strings. So you're going to see that the first part is the quick brown fox, the second part jumps over the lazy dog, and then I have a phrase here, and I'm able to print out that phrase. Let me, for the time being, get rid of these. And you'll see that if I go ahead and print what phrase is, you'll see that it actually prints both parts put together, which is really kind of nice. And I get everything that I want. I even added in a little space here so that I can have a space between the word fox and jumps, so that way it doesn't run together. So this is what we call concatenation, the joining or addition of strings. Now, once you have that put together, there are lots of things that you can do in a very similar manner to lists, okay, and tuples. Lists and tuples, along with strings, are sequences, and sequences can be indexed. You can find elements from them. It just so happens that the elements from a string have to be characters. They can't be anything else. Like with a list, they can be strings, they can be numbers, they could be floats, they could be audio files, they could be aliens, they could be anything you really need them to be. But with a string, obviously, it's just going to be a collection of characters. So if I want to access the first character of a string, I can do that very simply by saying phrase, this name of the sequence, and then follow it up with the square brackets and place some sort of integer in there. If I want the very first character, the first integer is always 0. Everything's 0 based in terms of its length or distance from where its beginning is. So 0 is the very first index. Whereas with my character, my string, 8 would then be the 9th character in the sequence, because remember, it's 0 based again. If I want to get to the last character, again, I have two different ways of doing it. The length of the phrase will return how many characters are in the phrase. If I subtract 1 from that, it'll put me at the very last character in the phrase. But again, if I wanted to access that last character in a more reasonable fashion, I can always add in a -1 there, and you can see that it brings up the very last character in there. So then again, there's the first character, T, the. There's the 9th character, K. There's the last character, a G, and the last character, again, a G. So now, the matter of fact is, if you can index them, you can also slice them, which means you can grab just a chunk from the phrase. So here's the deal for slicing. Let's say I wanted the first 3 characters. I can plug in any indices that I want here and slice them just like I did with lists. I can go from 4 to 7, from 4 to 9, whatever it is. But if I want to go from the first character to, say, the 3rd character, up to but not including, this will give me that first word, the, and you can see THE because it sends out period, or indices 0, 1, 2, we don't actually include the last index. If I wanted the 10th character to the end, brown fox jumps over the lazy dog, well, I can get that and get that 10th character all the way to the end, because remember, we're working with phrase, which is the concatenation of the two first part and second part. So there's a nice little way to kind of slice and dice everything and kind of mix it up and work your way through. Now, the last thing that I want to talk about in terms of processing it is the fact that you actually can't go and manipulate any of the elements within a string. So the one thing that I want to cause that will cause issues compared to lists is within a list you can go in and you can change any one element. You can say I want the fourth element to become this, and I can assign it to whatever it is I want to assign it to. With a string you can't do that because strings are inevitably immutable. So you'll see that we run into this little runtime error here. So as it gets to phrase at 0, if I wanted to change it to a capital T so it starts off more like a sentence, it's going to say that it doesn't support item assignment. Why? Because strings are immutable as we start working our way through. So I can't go through and change any character within a string using this sort of assignment statement. Now, if I need to change a character in a string, there are ways to do it, okay? There are methods that allow us to do that and functions that allow us to do that, but in this way, you absolutely cannot. So hopefully that all makes sense and it helps out. Let's move into some of the methods that we want to work with, and we'll show you how you can replace some of those things and work your way through them. Actually, before we do that, let's go back to the processing, and let's show you the looping structures that you can use. So a for loop is oftentimes really useful in order to process a phrase. So let's just say we have our quick brown fox jumps over the lazy dog, and I wanted to count how many characters were in there using something other than the length thing, because I want to, or length function, because I want to count how many specific characters in there. So let's say I wanted to go through there and just count how many lowercase o's there were. Okay, so now I can go through it and I can loop through each character in the phrase. We've done this in the past where I say for char in phrase. Phrase is the sequence. Char is the element that's going to get pulled from the sequence each and every iteration. And then I can use that element, that character, to do something with it. And I can compare it to something and work with it, make my way through. This copy paste did not copy and paste my spacing over, so give me 1 second to clean that up. And there we go. So let's give it a shot and see what happens. So here it says that there are 4 O's in the phrase, and it actually makes sense because there's 1 here, 2, 3, and 4 in dog as we start working our way through. So processing something really isn't all that complicated as you're working your way through. Let's try this one as well. We can work with changing up our string ever so slightly if need be. So here, let's say I wanted to process it and I wanted to write the phrase, but it doesn't include any variables, okay? So I have a variable called output here. Now I'm not actually going to change the phrase, I'm going to build a brand new one, okay? Since it's immutable, I can't actually change the phrase, I can't remove the vowels from it, but what I can do is create a brand new one that has all of the characters except for the vowels. So how do I go about doing that? Well, I keep track of a new output. I go through every character in the phrase. This output is a string, even though it's empty, it is a string. I say if the character's not in these lowercase vowels, I'm going to increase the output by the character. Now this may seem a little weird to you because you just said, well, strings are immutable, how am I supposed to keep adding things to it? Well, the fact of the matter is I'm not really adding things to it. I'm destroying the old one and increasing it by another character. If you think about it, this is the exact same thing as saying output equals, so I'm making a brand new assignment, output plus char. So I'm taking whatever the old output was, I'm increasing it by char. There's the concatenation piece, and I'm assigning it to the variable output again. So it's getting destroyed and then rebuilt into something more and something better each and every time. So that's a little bit different. I'm not assigning anything, I'm not mutating it by any means. I am completely erasing what once was output and making it something new. So if I go through and run this, you're going to see now I get the sentence that has no vowels included. Everything else is included, okay? Now, I can't mutate it, but there are ways to kind of go through and mutate these things with methods. So let's go over some of the more popular string methods as we work our way through. The first section of methods that I want to work through are what we call testing methods, okay? And again, my indentation is not copying over extremely well, so let me fix that real quick. Okay, so here's what we have. Let's say I have a name, it's just Brandon2, and I put the digit in there so that we can test some other methods here. Here I've got name.isAlpha, name.isDigit, name.isAlpha, lnum. What do these do? Well, the fact of the matter is, name is the object that holds the string. These are the functions that I can call upon those strings to do certain things. The isAlpha will return true or false. IsDigit will return true or false. Name.isAlNum will return true or false. They're Boolean methods that will allow me to determine if it's just alpha characters, if it's just digit characters, if it's alphanumeric characters. And as I run myself through this, you're going to see that first it returns false for isAlpha. Why? Well, because there's a 2 in there, so it's not just straight alpha characters. Is it digit? Well, that's going to return false because guess what? There are regular characters in here, not just digits. Is it alnum? That returns true because it has alphanumeric characters in it. So there's no special symbols like an @ sign or a $sign or a pound sign. But what we do have is just characters, alpha digits, and regular old digits. And then I can put name.isAlpha, name contains only letters, else you must be Elon's kid. Well, it prints you must be Elon's kid simply because there is a digit in there as well. So kind of interesting where you can go through and do some testing, but it doesn't matter. There are many other testing methods out there that you can work with. Find them, use them. They all get used essentially the exact same way. The variable that contains the string, dot, and then use the function as you work your way through. Now, a lot of other things that you're going to have to work with are modification methods. So let me bring those over. Okay, and again, my indentation is a real goofy, so let me fix that real quick. I'm going to comment these out so we're not working with those anymore. Okay, your modification method. So here I have a phrase. It says the quick brown fox, okay? But you'll notice there is a bunch of white space before and after the characters in the string, the first and last characters. Modification methods are pretty simple. They return a modified version of the string, okay? Now, they don't modify the phrase. You're going to notice that when I do phrase.lower and phrase.upper and then print the phrase again, the phrase doesn't actually get changed. But what it will do is return a modified version of it, so you can reassign if necessary. So let's go through those and see what that looks like. So you're going to notice in the first one, the quick brown fox changes to all lowercase versions, so all the uppercase letters turn to lowercase letters. It does still contain all the spacing to the left and to the right of, excuse me, of the first and last character. The dot is upper will return everything in uppercase letters. And then you'll notice that when I print phrase again, it is still unchanged. So it didn't actually change the phrase. If I wanted to change the phrase, I would have to say something like phrase equals phrase.lower or phrase.upper to work my way through. Now there are methods here that will allow you to strip white space from it. So notice here when I do phrase.lstrip, what happens is it takes all the white space in front but leaves the white space behind. If I wanted the white space behind to get stripped, I can use an rstrip. And it will do something very similar, so notice that there's no more white space to the right of that statement as compared to the one above it. Now the lstrip's obviously a little bit easier to see as you're working your way through, and you can work with that as you need, okay? Now the lstrip method and the right strip method, and even just the strip method, if you just strip, okay, whoops. Let's run that one more time. The strip method will allow you to just strip both characters, the right and left, at the very same time. Now the left strip, right strip, they also have arguments that you can send it, so you can tell it what to strip. If you don't send it any arguments, it's going to strip white space. But let's say I've got a name here, it says Mr. Brandon Berskevich, and I wanted to just strip off any of the Mr. part, Mr. period space. And so what it'll do then is just take off that part that precedes the string. Now if this part existed anywhere else in the string, it would not remove it by any means, but what it will do is remove those first characters from the string as it works its way through. And you can do that with a right strip as well. Let's say you wanted to get rid of like the .com or the .org from an email address or whatever it is. You absolutely could do that and remove those so that you can get just the username as you're working your way through. Okay. So those are some simple modification methods that you can work with. Okay. Searching methods. Let's try some of those. Okay, let me get this indentation right. Okay, searching methods are a way for you to find elements within strings, okay, and then do something with them. So let's say I have an email address. There's my email address for COD, berskevich@cod.edu. Let's say I just wanted to see what it ends with. Email.endswith.com, email.find an X, email equals email.replace, and then print the email. Let's see what these return and do for us. So you're going to see the ends with, okay, returns false, okay. Why does it return false? Because it actually ends with .edu, not .com. If it was .edu in there as the argument, it would obviously return true. So there's a nice little way to search for something that happens at the end of the string. There's also begins with, so you can check to see if something begins at a string. The find method is interesting because it'll return where something is located. So I put in the X here because it returns actually a -1 because an X doesn't exist in my email address at all. If I were to replace this with a Z, however, you'll notice that it returns the index in which the first Z occurs, 0, 1, 2 for the first Z. If I wanted to find the next one, I can tell it to start searching in a different location and it will find it in that other location. But what you need to know about the find method, it actually returns an integer, not true or false. Did it find it? Not what we're interested in. Where it is what the find method will do for us, and it will return a -1 if it cannot find it for any particular reason. Now notice here there's also this other little bit of, I guess I should put this in a modification method, the replace, but it also searches as well. The email.replace, and what I can do here is this method is a return method, much like all the other ones. So it will replace anywhere it finds this edu with a .com. So you find out, tell us what you want to search for, and then what you want to replace it with. Okay, and everywhere this .edu would occur in the string, it would then replace it with a .com. I could pass in a third argument here to say the maximum number of replacements to happen, but most of the time that's not really necessary. But remember, this is a return method, so you will have to make sure that you set it equal to something or reassign something so that it actually can do what it's going to do. So yes, it will replace it, but it's a return method, so you have to make sure that you work with it in the sense that a return method is working for. Okay, so those are some nice searching methods to kind of work your way through. And the last one is if you ever need to manipulate a string into something else, you can split them very easily. Let's see what this one does real quick. You're going to notice that this actually turns it into a list. And what it does is it will split the string based upon some sort of delimiter. By default, the delimiter is a space, and so you'll notice that every entry in this list is now one of the words from the string. So if you need to process a string word by word, you can easily do that by first splitting it into a list, and then you can iterate through the list and do something with each element within the list. So that's fairly simple to work with. Now there are many, many, many more methods out there that you can work with when it comes to strings. The book has plenty of them in there, like being able to right strip or change things to uppercase or lowercase and things of that nature, to find, replace, see if something starts with a certain character. And then there are tons of them that are just within the Python documentation as well. You can find all of that online, and feel free to use any methods that you need in order to do whatever it is you're going to do when it comes to processing strings. But that is essentially how it works. When you're working with a string method, you are simply naming the string dot the method. The method is always going to be a return method, and then you can use it in the way that you see fit. Hopefully that all makes sense. If you have any questions, please let me know, and I'd be happy to help you with lab or any assignments that you have come in your way. So we'll see you in the next video.